Welcome to today's video. Today's video is for Advanced Geometry Chapter 1, Section 3, Points, Lines, and Planes. So we start out with three things that actually do not have a definition. So these, even though they're in yellow and they look like definitions, these are really just a way so that we can talk about geometry. They're an understanding, but they are not definitions. So a point is considered a location. It has no size, and it's named with a capital letter. So if I want to talk about a point in space, I can draw the point and I can give it a capital letter A, and then I can call it point A. Space is a set of all points. A line is a series of points that extends in opposite directions without end. And if I want to talk about a line, there are a couple ways that I can name a line. So I can put a line and I can put 2 points on it. And if I want, I can call this line CD, and when I name it, I put a line symbol above. I can also use a lowercase letter, so if I put a little n, now n is not on the line, n is just used to name the line, so it's lowercase. I can also say line n. Okay. So there are a couple ways that I can talk about lines. Collinear points, in the last video I said they're points that lie on the same line. So an example are points E, F, and C collinear. So when I look at them for this one, I can see that they are all on this line, which is line M. So yes, they are collinear. And they lie on line M. And if I wanted to call it line EF or FC, I could also do that. Now, one thing to understand about collinear, though, is the line doesn't have to be drawn. So, for example, I can say, are FP collinear? And yes, because there is a line that I could draw through those points, and they would be on the same line. So, P and F are collinear even if the line's not drawn. Are points E, F, and D collinear? Well, if you look at those, here's E and F, and D's over here. There's no way I can draw a line that's straight that would go through those three, so this is a no. A plane is a flat surface that has no thickness. It contains many lines and extends without end in the direction of all of its lines. So we kind of like to think of a plane as being like, sometimes you'll see me say like the ceiling. And really what I'm saying is, if you took the ceiling and you made it so it had no thickness, okay, so it was incredibly thin, it had no thickness whatsoever, and then you also extended it forever in every direction, that would be a plane. Okay? So often when I talk about the plane of the board, the plane of the wall, those are not the planes themselves, but if you extended it forever and made it incredibly thin so it had no thickness, then that would be a plane. Coplanar, points or lines that are in the same plane. So if I draw a plane, and a lot of the times I'll draw a plane that kind of looks like a piece of paper. I really can't draw it extending forever. So when I draw it, we just have to realize that that represents a plane, but it would go on forever. Points can be coplanar. Points and lines could be coplanar. Naming a plane. A plane can be named with a single capital letter or by at least 3 of its non-collinear points. Okay. So if I draw another plane, and I draw a line on it, and then I put 3 points on this line, 1, 2, 3, and I call them A, B, and C. The problem with naming this plane ABC is there's actually infinite planes that go through that line. There's another plane that, could come out of the paper and go through that line. And you think about any angle that would intercept that line, they're going to be on that plane also. So it's not a unique plane that goes through those 3 points. So as long as I make the points not collinear, then there's only one plane. So when I name a plane, I can either use a single capital letter, so I can call this, plane M, or if I want, I can put 3 points on it, E, F, and G, and I can call it plane E, F, and G. So I can call it plane M, or plane E, F, G. Okay, so an example, each surface of the cube represents part of a plane. Name the plane represented by the front of the cube. So if I take a look at the front of the cube, there's 4 points that are listed, E, F, B, and A. As long as I use 3 of those, then I can name the plane. So I'll call this plane A, B, F. Make sure you put the word plane. There's no symbol for plane. Don't try to put a rectangle or something like that. Just write out the word plane. Don't abbreviate it PL or something like that. Write it out. We will have lots of postulates or axioms. I call them postulates if you want to be crazy and call them axioms. Okay. It's an accepted, there really should be an N there, an accepted statement of fact. Okay. The difference between postulates and theorems, which we're going to get a little later, are that postulates are not provable. We have to accept them as a statement of fact. And we want you to know if something's a postulate or a theorem because we want you to know if it's provable or not. What you'll find is that for most sections or chapters, there'll be a set of postulates, or maybe sometimes one postulate, that is an accepted statement of fact, and then all the other theorems are provable using that postulate, which means that if you could ever show a counterexample for the postulate, you would ruin all the theorems too. Okay, so a couple postulates. I highly recommend you write these down, keep them somewhere, have like little flashcards. You need to know these. You do not need to know these numbers. Please do not use postulate 1-1. Postulate 1-1 is because this is the chapter 1 and it's the first postulate in this chapter. You go to any other geometry book, they're going to name it something else. So calling it postulate 1-1 means nothing. What we'll do is we'll give an abbreviation for the name, and you can use that abbreviation, or if you want, you can just write out the postulate. As long as you get the main words or ideas of the postulate or theorem correct, you'll get full credit for it. Okay? You don't have to memorize it word for word. So if you put, any two points, exactly 1 line, that's fine. Okay? So the first postulate, through any 2 points, there's exactly 1 line. So this one is saying is if I draw any 2 points anywhere in space, there's only 1 line that can go through those 2 points. This is called the unique line postulate. The next one says, if lines intersect, then they intersect in exactly 1 point. So we have 2 lines here, and let me draw the little line things above them. AE and BD, and they intersect at C. And this one I like to call the intersecting lines postulate. You'll find that some of these already have a name, and it's in the same type as the book has. Those are ones that the book names. It's much more likely that if you go out somewhere else, someone's going to know them by that name. When I'm writing in my names, it's the way we're going to call it. Someone else might call it something slightly different, so it's kind of like a little way that we can talk geometry and all be on the same page. Okay, next postulate. If 2 planes intersect, then they intersect in exactly 1 line. So we have 2 planes, RST and plane STW, and they intersect, and when they intersect in ST. So this is intersecting planes postulate. Now we have a couple one example. What is the intersection of plane HGFE and plane BCGF? So HGFE is this top one, and BCGF is the side one. Now, the plane is not the top of the box or the side of the box. Imagine it went forever and ever. The intersection of a plane is always going to be a line. Make sure you label it as a line. That's the easiest way to get points taken off on the first quiz and test. So I'm going to say that these intersect at FG, and I'm going to make sure that I put the line symbol above it. Next postulate, through any three non-collinear points, there is exactly one plane. So this is the unique plane postulate. So notice the word non-collinear. If I say through any 3 points, there's exactly one plane, that's not true. If I make it a line, and I put 3 points on it, then there's not a unique plane that goes through them. There's infinite number of planes that go through those 3 points. The plane of the paper, the plane that would come out of the paper, anything that would intersect those. We're going to do, you'll see in the first few chapters, we have a lot of always, sometimes, never questions, and I'll take out words just to make sure that you know when it's unique, exactly, things like that. Shade the plane that contains A, B, and C, pretty easy. The bottom. Now I can't shade the whole plane, so obviously if I shade the bottom, I'm just showing you where that plane exists. Shade the plane that contains E, H, and C. So if you take a look at this one, I like this problem because it's not one of the sides of the box. They draw a box so you can see the 3D aspect of this figure, but planes exist that are not just sides of that box. So this plane is actually one that goes through the box. It's still there, even if it's not drawn, and it looks like that. And that's it for today's notes. Thank you for watching. Have a great day.